galaxies out there, and so each astronomer studies a different phase. And we piece them all together in order to understand galaxy evolution. So I study a phase in which the galaxy becomes extremely active. And we want to understand the structure of this phase in order to understand this phase better, in order to understand galaxy evolution better. So we know that there is a black hole at the center of almost every galaxy, and that the black hole and the rest of the galaxy are somehow linked because we see evidence of them growing together and affecting one another. We want to know exactly how these two components affect one another. So in this case, Renato is going to represent the black hole. Sometimes these black holes become very active in that they begin to eat all the matter around them and then spit it back out, which creates a lot of light.
Perfect!
The most luminous type of active black holes in galaxies are called quasars. And these quasars are so bright that they look exactly like a star in an image, hence the name quasi-stellar object. For example, in this image here, one of the points of light is a quasar and one is a star. Can you tell which one is which? No, I can't either, but Google says it's the one here on the left. Think about it like this. If you try to take a picture of your friend who's holding a spotlight pointed right at you, you won't see any of the details of your friend, or most of the image for that matter, because the spot of light is just so darn bright. So, we break the light up in two colors, and we look at a plot of the intensity, or how bright a color is, versus the color or the wavelength, called a spectrum. And from spectra, we can actually tell the composition, what the structure of the material is, and how fast the material is moving. And all we know about quasars is actually from these graphs called spectra. The word quasar describes the phenomenon happening at the heart of the galaxy. So you have the black hole, and then matter that is being pulled in to the black hole because of its extreme gravitational force. And it creates something called an accretion disk. So this is matter that is rotating around the black hole, and because of the extreme friction, that is what creates all of the light. So some of this matter also gets blown back into space into these jets. And then some of the matter also gets blown out in something called outflows, which is what I study. They come off like this. And then the last component is something called the dusty torus, which is a circular structure around the whole thing that is dust and gas. And then the rest of the galaxy is all the way over here. Remember how I said that we want to understand how the black hole and the rest of the galaxy affect one another and how they're linked? Well, scientists came up with this idea that maybe it's the outflowing material that then links the black hole and a surrounding galaxy. So our group is trying to understand whether this material being blown out can actually reach the rest of the galaxy and blow out the gas in the galaxy and therefore prevent stars from being formed anymore. So it's like a hairdryer blowing away pieces of paper. So our goal was to find where are these outflowing materials, what is the structure of them, and what is their kinetic energy. So what did we find? Well, we found that the material outflowing is quite close to the black hole and not all the way out here in the surrounding galaxy. We also found that the structure of these clouds actually are a dense core that is less ionized, surrounded by a less dense gas cloud that is more highly ionized. And lastly, we found that the kinetic energy of one of the quasars in our sample is marginally sufficient such that the outflowing material can affect the surrounding galaxy. So in conclusion, we were able to contribute to galaxy evolution by studying quasars and understanding the physical structure and the kinetic energy of these outflowing materials, and that they likely have enough kinetic energy to affect the surrounding galaxy. Our work was studying a snapshot of a specific phase of galaxy evolution, and this must be put in context of the whole cosmic scrapbook of galaxy evolution.